Simplify using division. So what we're going to do in these problems is we're going to take a look at these division problems, which are written as fractions. Remember that fractions are really just division problems. We're going to take 2 times the square root of 8 divided by the square root of 4. So this is problem 10 that I've just recopied. And what we're going to do is we're going to get the prime factorization of everything involved here. So let's start with getting the prime factorization of this, and we even do it for 2. So the prime factorization of 2 is just 2 because 2 is prime. And I'm going to multiply, or put my multiplication symbol there so that I'm thinking of this as a list of prime factors. And now I need the prime factorization of 8, which is 2 times 2 times 2. Now I'm going to do the same thing here at the bottom. The prime factorization of 4 is 2 times 2. And now I'm going to use some properties of radicals to break this up. Namely, that if I have all of these things under a radical being multiplied, I can break them apart like this. So these two things mean the same. 2 times the square root of 2 times the square root of 2 times the square root of 2 divided by, and then I'm going to break this up just like that. Square root of 2 times the square root of 2. And the nice thing about this is that now this leaves me with a nice fraction where I've got things being multiplied on the top and bottom. And when you have all multiplication symbols, no addition or subtraction symbols, but when it's all multiplication along the top and the bottom, you can look for anything that occurs in the top and in the bottom. And what this means is that we're taking the square root of 2 divided by the square root of 2. Well, anything divided by itself is going to be equal to 1, and so doesn't change anything when you multiply by 1, which means we can cancel out, if you want to use the common expression for it, anything that's the same on the top and bottom. So here we have a square root of 2 and a square root of 2, a square root of 2 and a square root of 2. Everything on the bottom disappears, which means I no longer have to write this as a fraction. I can just write what's on top, which is going to be 2 times the square root of 2, and there is my simplified answer. So let's try this again on number 11. For number 11, I have 2 times the square root of 20 over the square root of 9, and I'm going to go ahead and get the prime factorization of everything. So I have 2, that's prime, so I don't have anything to factor there. 20 is 2 times 2 times 5, and 9 is 3 times 3. So I'm going to break these apart into individual pieces. Times the square root of 2 times the square root of 5. Square root of 3 times the square root of 3, and look for anything that I can cancel. And do you notice anything I can cancel? Yeah, me either. There's nothing. So really, all I can do is put this back together. So if I take 2 times square root of 2 times the square root of 2, but check that out. It's the square root of 2 times the square root of 2. That's just 2. It's like over here where we pulled this one out. It's the same thing here. The square root of 2 times the square root of 2 is just 2. So when I multiply this together, I'm going to get 2 times 2, which is 4 times the square root of 5, over the square root of 3 times the square root of 3. Well, that's the same thing as the square root of 3 squared. So that's just going to be 3. And when I put it back together, I get that. Now, the reason I'm taking them apart like this is that I want to look for things that can cancel. Here we notice there's nothing that's the same in the numerator and the denominator, so nothing's going to cancel. So if it helps, if you were confused by putting this back together into this, if you get to this point and there's nothing that can cancel, go back to this point right here and just simplify those radicals just as we were doing before. So here you would pull out a 2, you'd have 2 times 2, and you have the remainder here. You would pull out a 3, and that just gives you a 3. And that's going to give you this answer by shortcutting this step. All right, let's try that process again with number 12. I have 2 times the square root of 15 over 3 times the square root of 3. I get the prime factorization of everything. 2's prime, so that's easy. 15 is 3 times 5. 3 is prime in both of these, so that's as good as I can get. Separate it out so that each piece under the radical gets its own radical. Oh, nice. Look for things that can cancel. That square root of 3 will go away. It turns into 1. Multiplying by 1 changes nothing. And so I'm left with 2 times the square root of 5 over 3, which is my final simplified answer.